Let's apply implicit differentiation to looking at selling some houses. We have a study prepared for the National Association of Realtors estimates that the number of housing starts in the Southwest is given by this N of T in millions. So this is number of houses being built over the next 5 years is related to the mortgage rate, R of T, which is in percent per year. And their relationship is given by this equation here. We're going to take that equation and we're going to end up taking the derivative of it with respect to time. So we have 9n squared plus r equals 36. And hey, if you're just interested in getting as much credit on these problems as possible, you can jump right into taking the derivative with respect to time or do the setup with the variables on the side first, whichever you prefer. Maybe this one I'll take the derivative right away. With respect to time though, so I'm going to bring down the power. 9 times 2 is going to give me 18n. dn dt. Derivative of 1r is 1. dr dt. Don't necessarily have to write that 1 because multiplying by 1 doesn't change anything. Equals the derivative of 36 is 0. So there's our equation, its derivative that we're going to be plugging into. And we're going to have to figure out a bunch of numbers that are given to us. So I'm going to do my setup off to the side. My equation has a capital N and a lowercase r, so I'm going to have an N and an R. And then with their derivatives, I'm going to get a dn, dt, and a dr dt. These rates are related, which makes sense. The higher the mortgage rate, the less people can afford to take out a mortgage, and the lower the mortgage rate drops, the more people are building houses or buying houses. So we are given N of T is measured in units of a million. So when we get N and it's 2, it doesn't mean 2 houses are being built in the Southwest. It means 2 million. So dn dt is going to be in million of housing starts per, what's the time frame for this one? Last one, we could have weeks, months, years. Let's look at this. Over the next 5 years is related to the mortgage rate where T is measured in years. So this is going to be millions of houses being started per year. And then R of T is the percent per year for that mortgage rate. So we have the percent per year. So then dr dt is going to be how that percent per year is changing each year. Kind of a big unit on there. So you have the percent per year as your mortgage rate, but then how it's changing each year would be dr dt. So looking at these numbers we are given, we want to place them appropriately as either n, r, or their derivatives. So it says, what is the rate of change in the number of housing starts? So we want to figure out what is the rate of change in the number of housing starts. Do you think that's dn dt we're finding or dr dt? Well, the number of housing starts in millions is n, so we must be looking for dn dt. We want to see how is that changing. With respect to time, when the mortgage rate is 11% per year and increasing at a rate of 1.5% per year. So we have to figure out which one of these mortgage rate is at 11% per year and increasing at 1.5% per year. We want to figure out which one of these is R and which one's dr dt. Neither are going to be N because they're not measured in millions. So right now, the mortgage rate is 11%. That is our R. Increasing at a rate, so increasing at a rate, this must be the derivative, is 1.5. And we want to think, is that a positive 1.5 or a negative 1.5? Because with derivatives, the sign matters. And since it's increasing, it's a positive derivative. If they were dropping their mortgage rate by 1.5%, we would plug that in as a negative 1.5. So we're trying to find dn dt, but we're missing n as well. So we're always missing one of the derivatives, but if we're missing a variable, we're missing n, and we need it to plug in right here to the derivative. So if you're missing a variable, plug in to the original equation. That's how we're going to find it. So I'm going to plug in 9n squared plus the current rate is 11% equals 36. I'm plugging right into this original equation because yes, I'm missing the derivative. I'm always given one derivative and asked about the other. Right now we're looking to increase our mortgage rate. What's going to happen to the number of housing starts? Are we going to lose all our clients? Nobody's going to start building houses, or is the market going to be okay? But if we're missing a variable, that's a problem. We need to plug into the original equation. We should always be missing a derivative. That's what we're solving for, but we shouldn't be missing a variable. So I'm going to plug in 11 for R and solve for N. See what the number of housing starts is with this current mortgage rate. So I'm going to get N by itself first by subtracting 11. It's going to give me 9n squared equals 25. I can divide by 9 next. N squared equals 25 divided by 9. And to get N by itself, I need to do the square root of both sides. When you square root a number, you always have plus or minus the square root. And we could take a regular square root here, regular square root of the top and bottom. So square root of 25 is 5, square root of 9 is 3. So our answers are positive 5/3 and negative 5/3. They're building 5/3 of a house? No, that's in millions. So 5/3 of a million, which is plenty of houses. And we know we can't have a negative number of houses being built. You can have a negative derivative, but you can't have a negative variable for this one. So N must be 5/3 million houses right now. So now I can plug in and solve for d and dt, figure out how is this mortgage rate increase going to impact the number of housing starts, which already having an 11% mortgage rate is crazy. So I would think that this number of housing starts would really decrease if they're going to keep making that mortgage rate even higher. But let's see. So I'm going to plug in 18 times, I'm going to replace n, which was that 5/3, times d and dt, that's what we're solving for. Going to be in millions of housing starts per year. Plus, on the other side, we have 1 times drdt, which is going to be 1 times 1.5, or 1.5. I can multiply these two numbers together. So 18 times 5/3 is going to be 30. dn dt plus 1.5 equals 0. I want to get dn dt on one side by itself. So I'm going to subtract the 1.5 over, which will give me 30 dn dt. So 30 times dn dt equals negative 1.5. And so last thing, divide by that 30. Which negative 1.5 divided by 30 is about negative 0.05. And remember, you want to look back at your setup. This is in millions of housing starts per year. Million houses per year, which doesn't make too much sense to me. So at the end, I usually like to multiply out by these amounts. So I'm going to multiply by 1,000,000 and see how many that is. That is really going to be negative 50,000 houses per year. So our conclusion, you want to say, what was the rate you're given? We're going to say, as the mortgage rate increases by 1.5% per year each year, what's happening? Well, we got a negative answer. So as that mortgage rate is increasing by that 1.5% per year each year, the number of housing starts is doing what? Increasing or decreasing? It's decreasing. buy 50,000 houses per year. So they have to decide, is it really worth it to be raising mortgage rates if they're going to sell 50,000 less houses that year when they do that? As mortgage rates go up, the houses go down. That makes sense to me. I would be concerned if I got a positive answer. Maybe during some crazy, unprecedented times, you could have mortgage rates go up and people are still going crazy buying houses. But normally, mortgage rates go up, the number of people buying or building houses is going to go down as a result. I can't afford to build or buy anything at that point.